Okay, first thing, when we started class, the lunar orbiter or the Artemis orbiter, the Orion orbiter, was 1,000 miles from the moon, moving closer at 50 miles per minute. Okay. That was actually moving at over 4,000 miles an hour, which is over 60 miles a minute, but getting closer to the moon at 50 miles per minute. Relative to the Earth, it was moving at 60 miles per minute. Okay. Now you don't know how to deal with all that. That requires vectors and stuff, but this calculation, how long is it going to take to get there at this rate? Okay. Get to the moon. If it doesn't miss, and it better miss, it'll take 1,000 miles divided by 50 miles per minute, which is 20 minutes. Right? That's a rate. This is the rate at which the distance is changing. You divide that into the change in distance, and you get the time it takes. And it took about 20 minutes. It got there, pretty sure. It was approaching really fast, then slowed down, slowed down, slowed down, when it was about 100 miles away. And then NASA lost, I lost the NASA signal. Okay. Now they haven't called me to tell me there's a problem. So I pretty well assumed that everything went smoothly. Okay. So we've been looking at that, and I've been, actually taking data here and neglecting everybody just a little bit. But just like a once in a lifetime opportunity, not once in a life. Yeah. We haven't orbited, we haven't put an official orbit around the moon in your lifetime. Okay. Probably not in your parents' lifetime. It's been a while. Depends how old your parents are. They could be that old, not, but so that's kind of interesting. Okay, now we come over to a problem that's relevant, and doggone it, they're still disconnected. I don't know what's the matter with these people. How am I going to give them advice if they don't give me the data? Okay. So we have this function. Okay. It's a function. Remember, we did, if I ask you what's h of 50, what are you going to do? You're going to put 50 in here. And since you put 50 in for t, you put 50 in for this t, and you put 50 in for this t. I want to review what we did last time, because this is going to be really important to you right at the beginning of your pre-calculus course, what to do with a function of this nature. Okay, now I pose two questions. Okay, that is two. Yeah, okay. Okay, we pose two questions. And these are typical questions you pose when you have a function. First of all, what is t when h equals 4,000? Okay. Now that's a harder question than this one. What is h when t equals 1,000? Okay. To get h and t equals not 1,100. If you get h and t is 100, that means h of t is going to be 100. So let's get over here. You didn't need many hints of this while we were trying to get data. I gave you several hints of what to do with the first question. The second question, actually try to find h. Well, now I've just written the equation down here. You can say H of 100 plug in 100. Okay, you've let T equal 100. So you get minus 5 times T squared. That becomes minus 5 times 100 squared. Remember last time we just learned that when you have a number in here that replaces T, you got to replace all the T's. So maybe we're reviewing that concept just a little bit. And then it's going to be, I'll just write the rest down here so I've got room. Okay, write that out. Well, if you do the arithmetic, this is negative 50,000 plus 80,000. I still didn't leave myself room, plus 200. Okay, and that's going to be negative 50,000 and 80,000 is 30,000. Now, you might not have seen negative in front of here, although for once it was clear. So if you didn't write the negative in front of this, it's going to change a lot of what you get, but still the process is going to be the same. So being careful to have a negative in front of here, get the negative here and add the 80,000. Negative 50,000 and 80,000 is 30,000. So you get 29,800. Okay. Now, we define T when H equals 4,000. And actually, the way I stated it was H equals 4,000. I didn't put the T in there. You got to get used to that because that's a common way to say it. We say H is 4,000. Well, H of T is H. Okay. So we could say, if we wanted to, H equals H of T, meaning H is how high something is. And H of T is the function. It has this form. Now we've got a question, so let's stop and make sure we got that answered. Okay, several questions on the mechanics. First of all, I made a mistake here. I subtracted 200 when I should have added 200. So any mistake you made, you're forgiven for it since I made that bonehead mistake, okay? But let's be clear on some of the other questions. I should have gotten 30,000. Okay, now, first place people have tended to make a mistake is in calculating negative 5 times 100 squared. Remember, the order of operations says you do exponentiation before you do multiplication, which means you have to square this 100 before you multiply it by negative 5. Okay. So let's make a note. That's one error that I saw. Okay. And that's how you get a negative 50,000. because 100 squared is 10,000. Another error I saw, if you're just careful, you won't make that one. You didn't have enough zeros when you squared it up. There are 4 zeros, you wrote 3. Okay, so you just got to be careful. You're not going to make that error if you're really careful, like I never am. Okay, so you try to be too much like me. Okay, then the rest of the calculation comes out really easy. Of course, you got to have a negative here. A lot of people got a positive. Of course, that is what you get if you thought you were squaring that negative, but you're not. You're only squaring the 100. Okay, then we add them up, and if you add the 200 instead of subtracting it, because like I did, you get 30,200. So the original question was this, but then we digress back to questions about these numbers. Okay, so that's where the numbers go. Now, where we're at here, let's just refresh. I asked what is t when h equals 4,000. So we want to find t when h equals 4,000. Now I had h of t written here. But if h is 4,000, then h of t is 4,000. I wrote now h equals h of t. Again, the reason I wrote h equals h of t is h stands for the height. And h of t is a function that gives you the height. So if you were going to graph this, you put h on the vertical axis and t on the horizontal axis. Now we're not going to go as far as to do the graph of this thing, but I'll kind of mention the way it looks. Okay. Because in order to do the graph of this function using the methods of pre-calculus, you got to do a bunch of stuff that we're not going to talk to. It all comes out in quadratic form. So you really have to know this. Okay. Okay, so end of digression. To find t when h is 4,000, h is your h of t. So we plug in 4,000 for h of t. And we get 4,000 equals negative 5t squared. Plus 800t plus 200. Now I demonstrated this over here. I said, you can solve h of t equals this for h equals 4,000. That's something else. Plug a 0. Okay. So we're going to write 4,000 instead of h of t, same equation that I've got here. Okay. Then, as I said over here, I'll go ahead and write it out. We get this. How do we get this? We subtract 4,000 from both sides. Standard procedure with equations. Multiply both sides by the same quantity, divide, as long as the quantity isn't 0. Multiply, add or subtract, same quantity on both sides of the equation. Okay, so this is AT squared plus BT plus C equals 0. Now you might review, because recently, within the last week or so, maybe 2 weeks, we worked on the quadratic formula. Okay. And the homework that we do today assumes that you know how to use a quadratic formula. And if you don't, well, you lost track of something that you knew 2 weeks ago. Okay. Go back and review it. You had it. You can do it. Now, this tells us A is the number in front of t squared. It's negative 5. Now, I wrote all that down over here as hint, but not everybody got it. Because there's always a tendency to want to include that t squared in A. A is not negative 5t squared. A is the number in front of t squared, which is negative 5. B is the number or quantity in front of t, which is 800. And C, what do we add to get a negative 3,800. Well, we had a negative 3,800. So now just plug these quantities into the quadratic formula. Remember, part of the quadratic formula, it really starts with the equation has to be AT squared plus BT plus C equals 0. If you don't have a 0 over here, you're going to have to add or subtract stuff to get it. Okay. Once you have it in this form, then you plug the numbers into the formula and process the numbers correctly. Now, saw a couple of errors processing these numbers, so let's be clear on this. First of all, you get negative B. You know what? I'll get myself caught by the end of the board because I am going to have to make a couple of corrections. Bring this all the way up here. Okay. So now, then I can write it there. Already. Yes. Okay, now. I like being close to the top of the board because I can write zeros down here. Hard to write. Okay. Okay, so we get this, right? Just plug in the numbers in. I've done nothing but replaced A's with negative 5s, B's with 800s, C's with negative 3,800s. Now things get a little shorter, which is good. I don't want to go through this line again. First of all, it's easy. You get a negative 800 here, you get a negative 10 down here. Up here, 800 squared is 640,000. And this is negative 76,000. This gives you negative 800 plus or minus the square root of 564,000 over negative 10. Now, one thing you absolutely can never do is you can't divide this negative 10 into 560,000 because at 560,000 there's square root. That just totally violates all the rules of exponents. Okay. You have to get a number here before you can divide it by negative 10. And then when you do divide by negative 10, remember you got to divide this and this. Okay. It's a distributive line. Okay. So we're going to write that out more systematically. We're actually going to get numbers. So you don't have to worry about what I just said, but that's still something you need to understand. Now, this is probably pretty close to 750. It's up pretty close to 750 when you punch that in. Okay, so it does come out really close to 750. Somebody's calculator had a big check mark in front of all the decimals, which is really not a great feature. So you can't even read the stupid decimals. But it gave you 750, which is good enough. Okay. And no insult to your calculator. It's got a really beautiful display. Okay. It's actually showing you too much, which can be misleading. Okay, so this gives us two numbers. This gives us negative 800. Okay, it's 5 or 155 if you complete the solution. Okay, remember, use your calculator for every step. Sometimes your calculator wants to show you all kinds of stuff. You know, it shows you the steps in a solution and explains them. It explains more than you're in a position right now to understand. You want to just go with the calculator. If you use anything more than a calculator to plug these numbers in and so forth, it's going to bite you. Okay, and you really have to do it yourself. After you learn to do it yourself, then all the steps the calculator might explain to you can be really informative. Okay, but a lot of times the calculator do something that goes beyond what we know at this point. Okay, so there we have it. Now, what is the good of this? Well, it's a lot more good than this NASA feed, which cut out at the critical point. And I'm going to check that NASA feed real quickly. Okay, now what's the point of this calculation? Well, the point is that this is a fairly realistic picture of what happens if you shoot something upward at 800 feet per second, 800 meters per second. Okay, now 800 meters per second is a appreciable fraction of the speed of sound. Means the air is going to really resist you. So if it wasn't for air resistance, so this would be the function. If you're 200 feet high and shoot something upward 200 meters high, okay, it's over 600 feet, so don't get too close to the edge. At 800 meters per second, and actually, I did that wrong. That's Mach, around Mach 3, 3 times the speed of sound. Okay. So it's going really fast, like over 2,000 miles an hour, which is like on the order of how fast this spacecraft is approaching the moon. Okay, it's really moving at several miles per second, or at an appreciable fraction of a mile per second. And this is the effect of gravity. You don't have to know the physics of that. I'm just explaining that if you did this on the moon, gravity would be a lot weaker. You have a smaller number there, and that would affect the result. Now that's just a little color. Just think of shooting something upward at an unbelievably fast velocity. Okay, almost a mile per second. On a planet much like the Earth, but with no atmosphere. Okay. Then we can answer these questions. Why did you want to answer this question? Well, how long does it take you before you're 4,000 meters high? Okay, 4,000 meters is 4 kilometers, it's close to 3 miles, 2.5 to 3 miles. Okay, that's about 2.5 miles. Okay, how long does it take it? If you want to hit a target up there, how long is it going to take it to get that high? Well, this says it's going to take about 5 seconds. 5 seconds, it'll be about 2.5 miles high. Gravity will have pulled back on it a little bit, but we don't want to get into that. Okay. Also, if you miss, it's going to keep going up, and then it's going to start falling back down. So at some point, it's going to fall through that 4,000 meter height. Okay. So it goes up in 5 seconds, it passes 4,000 meters. It keeps going up for quite a while, over 2 minutes. Well, over a minute. Okay. About 80 seconds. Okay. Then it falls back down. And at 155 seconds, it'll pass that 4,000 meters. Okay. If you want to know how long it's going to take before it falls in your head if you shot it straight up, which you probably did, but say you did. Well, you've got over 155 seconds to get out of the way. Turns out it's going to take another 5 seconds to fall back, the same 5 seconds it took to get up there at 4,000 meters. Okay, so you got a minute, 2 minutes and 40 seconds to move out of the way so that thing doesn't fall in your head. You better move pretty far out of your way because it's probably not going to go completely vertical, and you don't really want it to fall anywhere near you because it's going to be lethal. Okay, now that's one fairly involved example. In the homework, many of your examples just basically give you a function like this. Okay, can ask you a question. What's t when this function is equal to whatever? Or what's h when t equals this? Another one is, when does it end up back where it started? Okay. And in that case, it started at 200 meters. It just ends up back where it started when h is the same as it started. How do you know it started at 200 meters? Well, if t is 0, that's when it started. What do you get here? You get 0, right? What do you get here? You get 0. So when t equals 0, this is 200. Those are important aspects of this. Now, it's important to put this stuff in context. Okay. The problems give you a number of examples. The first one I saw on the homework was your blood pressure. It was P equals some function. Okay. It asked when's the blood pressure equal to 130 or whatever. You just set this equal to 130 and there's your answer. Same thing we did here, just a different situation. There are a whole lot of situations in business. Your profit ultimately depends on how much you charge. The more you charge, the fewer people are going to buy it. But of course, the more you're going to get for every person that does buy it. Okay. So if you look at your profit, if you start by charging 0, well, your profit's probably negative because it costs you money to make the things. Okay. Now you start charging money, at some point you get to where you're actually making a little bit of money. Okay. If you charge nothing, people probably take all that you can manufacture, right? Start charging a little bit and you start making some money, offset your manufacturing costs, but fewer people are going to take it. And go a little higher and you're going to hit where you're making some money. Charge a little more and you're making more money. Start charging too much though, and the number of people buying it falls off faster than the money you're making. So you have an arc that looks like this. If you remember your basic functions, they have a curve that looks like this. You can flip that curve upside down and move it wherever you want, and then figure out where the peak of that curve is. Now, I'm not going to explain the details of that. It's actually fairly straightforward once you have command of the quadratic formula and then learn a little bit more about what it's telling you. Okay. So we're not going to address this in this course, but there we have it. Now, I have one more class. Okay, so you got any questions about anything in the course? Ask them. I see somebody has a question, so